So I want to thank everyone for joining us today. This is amazing to see such a big turnout for our very first webinar. So I want to thank all of you for joining us today, taking the time and joining us to learn about MLflow and for this first exciting part of this webinar. So sharing knowledge or the knowledge that we gather at DagsHub throughout the years and sharing to the community and help promote machine learning and MLOps is definitely one of DagsHub's main values. And creating an MLflow course has been one of our tasks or something on our bucket list for a long time and something that we're keen on doing for a while. So launching this event or this two-part webinar is very exciting for us at DagsHub. I must say that I'm thrilled doing that and seeing such a big turnout today and having all of you with us. So I want to thank you all for joining. And before I'm going to give the mic to Shambhavi, our amazing ML researcher, I would mention that in this session, we're going to draw 5 amazing swag packs to you. So if you're going to follow along the entire tutorial, the practical tutorial with Shambhavi, you're going to complete it and send us your Colab notebook with your DagsHub repository with your first MLflow experiment logged there. Between the people that is going to send us those links, we're going to draw 5 swag packs with bottles, t-shirts, amazing stickers that were generated with DALL-E, which is even more amazing. And we're going to send them directly to your homes. So stay tuned. There's a lot of interesting thing coming. I'm going to share the notebook with all the materials on the chat here, so you can all follow along on Shambhavi's tutorial and session. And without any further ado, I want to welcome Shambhavi.
Thank you. It's a pleasure. It's my first time doing a webinar, and it's our first webinar at DagsHub, and I'm truly amazed to see the number of people who have turned out for the event, and so that we can start with the tutorial without much delay. Okay, let's get started. I hope all of you have already found the link to the notebook in the comments section. I would request you all to open it up so that you can follow along. Although there's not much that I want you to do right now, we'll go to the hands-on part after I've covered the theory, but it would be nice to have it open on another tab. Okay, thanks for sharing the link, Neil. Okay. So hello, everyone. I would like to welcome you all again to the first part of our MLflow crash course. And I'm Shambhavi. I'm a PhD research student in Montreal. And I'm going to cover the first introductory part of what is MLflow and how do we track MLflow. And in the next part, which will be held on 27th of September by my friend Yono, he'll log on to how to do model registry and model deployment, which will launch you to be on the path of being an MLflow ninja. That's how I'd like to call it. So before we get started, I don't want you to get deviated in the middle of the session while we are on our hands-on. So I'd like you to scroll down to your notebook, come on this part and sign up to DagsHub so that when I'll ask you to create a repository to follow along in the hands-on, you don't have to run here and there and miss out on whatever we are doing. And also because I really, really want you guys to grab the awesome cool swag packs, I want you to sign up and follow along and submit your tutorials later. Okay. So I'll give you 2 minutes for signing up, and till then I'll see if there's any question in the chat. If you're having any difficulty, feel free to put it in the chat. We'll help you debug it, and I'll give you 2 minutes and we'll resume once you have created your accounts. I hope you guys did not face any difficulty in signing up. You can simply use your GitHub credentials as well and link it through GitHub and it would work for you. But in case you do have any difficulty, please feel free to put it in the chat box and we'll help you figure it out. Another minute to go. Okay, the link to signing up, it's on the notebook. You just need to sign up to DagsHub, and it will take you to the platform. Okay, okay, just follow along. I'm sharing my screen and we'll do it together. I'll log out. Okay, let me just log out from my existing account. You just need to sign up, make an account, and like you don't have to choose any option right now. Just go to sign up, and there's a button over here on the right top. And it has also sent a link, or you can just click on this link and sign in with GitHub. And it's as simple as using your GitHub credentials to log in through GitHub or Google, whatever you prefer. Thanks for sharing the link. The link is in the comment section for those of you who, for whom the link was not working here in the notebook. You could just find it in the comment section. And just drop in if you have already done it so that I have a rough idea that, okay, sure. We shared the link to the notebook. I'll do it again. Okay, a lot of you have done, and it's nice. I see the swag bags flying away. Awesome. Okay, great. Okay, since most of you, okay, if you already have an account, awesome. You don't need to do anything. You just, you don't need to even go to that account. Everything is in the notebook. Don't worry. No, don't create a new repository. Just create an account and come back to the tutorial. You don't need to do anything. Okay. Now that I have your attention, let me get started with what all are we going to cover today. And okay, so we are going to start with, okay, there are more messages. Okay, okay, awesome. Okay, so we're going to cover why do we need MLflow. And once we understand the need for MLflow, we'll move on to what is MLflow. And then we'll be covering the MLflow tracking functionality. We'll be understanding what is a run, what is experiment, how to differentiate between the two, how to log them, and how and where are these runs being recorded. And once we're done with the theory aspect, we'll move on to the hands-on experience using MLflow. Okay, so let's get started. The ongoing concern about the amount of time that rule of data science. And in this case, the 80% represents the 80% of the time that data scientists spend getting data ready for use. And the 20% refers to the mere 20% of their time that goes into actual analysis and reporting. And if the number of memes was an indicator of how true a claim is, this would probably be a solid one. However, the effort and time spent in logging the experiments, code, parameters, metrics, and their outputs is always underestimated. Do you also find yourself doing control by multiple times to find that perfect code which gave you an awesome accuracy, or the confidence score that you always wanted before you messed it up with a new experiment that you decided to run, or that optimal set of hyperparameters that you used for that perfect run? And among all this manual hassle, another question that arises is of reproducibility of your experiments. This is how I used to structure my experiments using a Notion table to keep track of them. So I would log in the experiment details manually. I would log in the status, what's happening with them. I would come manually update the status, their outcomes, and every minute detail, like how many epochs took how much time, what was the associated metadata, log files. I used to put everything in a Notion table. And while I do agree that Notion is a great tool for note keeping, I don't think we can say the same when it comes to tracking the machine learning experimentation and workflow. The value of keeping a structured log of every experiment we run to increase that reproducibility cannot be overstated. Although our ideal is to always find the model that performs the best, it is often the unsuccessful trials and experiments that offer us a more comprehensive overview of our model's explainability. Beyond these experiments, a model must be developed, then deployed to a production system. Its performance has to be monitored. It has to be updated with fresh data, then contrasted with rival models as needed. The absence of a standardized deployment procedure and a host directory for all trained models is what is lacking in this approach. And I personally wanted a platform that would record not just the hyperparameters, but also my network architectures used for different experiments along with the file that I used to execute it. I also wanted to share all these experiments that I'm running, as well as the trained models that I finally get after those experiments with my teammates, so that we did not run into repeated ideas. And in the midst of all this hardship, I discovered MLflow, my savior. So now that we know why we need MLflow, I think it's time to introduce what is MLflow. So MLflow is an open source tool to manage the machine learning lifecycle. It supports live logging of parameters, metrics, metadata, and artifacts when running a machine learning experiment. To manage the post-training stage, it provides a model registry with deployment functionality to MLflow created. MLflow was created to address the issues of availability of numerous tools at each cycle of ML lifecycle to improve results, complexity in monitoring experiments, to help in reproducing the results, and to deal with the lack of a standardized mechanism to deploy these models to production. So when was it introduced? So Databricks introduced MLflow in June 2018 with the goal of being open in two ways. So is it like GitHub for ML models? There is a good question in the chat, although I'd prefer taking all the questions in the end, but this one, if you're talking about DagsHub, yes, DagsHub is like a GitHub for ML models, but MLflow is more of a tool to manage ML lifecycle for you. So coming back, so when was MLflow introduced? So MLflow was introduced in June 2018 by Databricks to offer two important open aspects, as I would like to call them. First was that it was an open interface tool. So any ML library, algorithm, deployment tool, or language can be used with MLflow. Instead of merely offering a limited set of built-in capabilities, it is designed on REST APIs and basic data formats. For example, a model can be seen as a Lambda function that can be utilized from a range of tools. This aspect also makes it simple to distribute code using any ML library that other members of your team may execute. And also it helps to add MLflow to your current existing ML code so that you can start benefiting from it right away. The second open aspect of MLflow is that it is an open source project and users and library developers can extend it. Additionally, if you want to open source your code, the open format of MLflow makes it very simple to share your workflow steps and models across organizations. So it's interesting to know what was happening before MLflow came into the picture. So prior to this, organizations like Facebook and Google had begun to develop their own platforms for managing the data preparation, model training, and deployment phases of the ML lifecycle. But these internal platforms also had some limitations because they were dependent on the infrastructure of each individual organizations, and they typically only supported a single ML library, or if not, then a narrow selection of built-in algorithms. Currently, major companies such as Microsoft, Zillow, Facebook, Booking.com, and Genpact use MLflow. And to give its client the most freedom possible, I'll give you an example. Microsoft supports open source MLflow in Azure Machine Learning. I've also added a link to the blog from where all these reference stats are, so that later, once you're done with the tutorial, you can explore how MLflow came into being. Okay, moving to the next important part. It is the MLflow components. What are the components that make up MLflow? So MLflow offers 4 components to help you manage your workflow. One is MLflow Tracking. So using MLflow Tracking, you can log your parameters, code versions, metrics, and artifacts when you're running your machine learning code. The second option is MLflow Projects, which is used for packaging reusable data science code. The third option is MLflow Registry, which helps you manage the whole lifespan of an MLflow model. It provides you a centralized model repository, a set of APIs, and user interface. And the last one is MLflow models. It is used for packaging machine learning models and deploying them. So today, we will be talking about tracking our ML experiments using MLflow. And furthermore, on September 27th, in the second part of our crash course, you will explore model registry for logging and managing your machine learning models with MLflow, and model deployment to deploy your trained model from the MLflow registry to AWS. Okay, so now it's time to move on to the MLflow tracking functionality. There are two concepts involved with MLflow tracking functionality, which are runs and experiments. While we must understand these two key ideas, we also must understand the differences between them so that we can comprehend the tracking feature provided by MLflow. So at the project level, experiments are frequently used to compare and query between several runs, and they can be understood as an overarching hypothesis. Simply said, depending on the team or user, the experiment unit in MLflow can be handled as a project or as an approach. On the other hand, the term run merely refers to a run or execution of a code once, and more than one run can be associated with a single experiment. To make things a bit more clear, I'll give you an example. So one could, for instance, want to transition between several backbone architectures for a project, say in test time adaptation, such as using various ResNets or a vision transformer. In this case, the test time adaptation project or TTA project is our experiment. And to make up this project, we will vary the project's backbones, that's the architectures, ResNet versus the VITs, and we'll record the runs for each of these configurations or combinations. Awesome. So now that we understand what is a run, what is an experiment, and we can differentiate between them, let us go through what exactly does each run record for you. So what information are these runs recording? Okay. So the first information is source of execution. So the source of execution actually contains the hash of the commit if the code was pushed to GitHub, and the original line of code that was utilized for the run. And it is advised that you commit just before starting the run if reproducibility is crucial to you. You would ask, why am I asking you to do that? So it's because MLflow will pull the commit from the repository the script is running from, and it will log it as a tag. So this will ensure that the link to the commit from the experiment table has a high level of integrity with the metrics displayed in the table. And also it should be noted that if you run the import MLflow command outside of a Git repository, as is the case mostly with Google Colab, then there will be no commit being reported. So it's important to make sure that you're importing MLflow inside the Git repository. Okay. The second part that is being recorded is artifacts. So what are artifacts? Artifacts are output files that are recorded during a run, and they could be in any format, such as images from graphs and plots, pickled models, or any other data files. Coming to parameters. So what is a parameter? Parameters are basically stored in a key value format. For example, you're storing maximum number of leaf nodes in a decision tree along with its value, or the depth of a random forest model. Don't worry if you're still not clear about how these are being stored. We'll cover all of them in the hands-on session, and I promise you will be an MLflow tracking ninja by the end of it. So the last part that's being recorded here is metrics. So you can custom define the metrics, or you can log metrics such as RMSE, ROC, AUC score. Okay, so now we understand what is a run, we understand what is experiment, and we know what will run record for us. Now we come to the aspect of how and where are these runs recorded. And this is the particular section where our users hit the wall the most. So I'm trying to be as detailed as possible. And in order for you to go beyond a cursory grasp of MLflow and become an MLflow ninja, let's go through each of these potential possibilities for fully addressing the problem. Okay. So the first scenario is MLflow on localhost. You will probably begin your MLflow experimentation here, since MLflow will create a directory called MLruns on your local system as soon as you import MLflow and log an artifact. While this is a good first-time technique to get started, it has limitations on collaborations because you won't actually be able to share your experiments or results with the team. They will be with you in files in your local directory as shown in the structure, right? If you want to visualize these results, you can use the MLflow UI. So to visualize, search, and compare the results, and as well as downloading the run artifacts or metadata, we will use the tracking UI. So if you log runs to a local ML runs directory, you can run the MLflow UI command in the directory above it, and it will load the corresponding run for you. So what does this UI do for you? What are the features? So the UI contains some key features, which are you can do an experiment-based run listing, and you can compare those experiments, those runs. Then you can search for these runs by parameter or metric values. You can visualize the run metrics, and you can also download these run results. Okay. The second scenario. The second scenario is running MLflow on localhost with a database, such as an SQLite. This one is pretty similar to the first scenario. The only difference between this process and the previous one is that here we use a local database such as SQLite instead of storing runs to files. Let's move to the third one. Again, third one is also super similar to the first scenario. The only difference being that here you can set up a remote server using the MLflow server command, and it will launch a tracking server for you at the default port 5000. Let's move to the fourth scenario. This one is one of the more complex scenarios where the tracking server, the backend store, the artifact store may all be located on different hosts in distributed architectures that MLflow also supports. For example, using a remote, I'll give you an example so that this setup is a bit more clear to you. So you can use a remote MLflow tracking server. You can use a Postgre database for storing the backend entities and an S3 bucket for storing the artifacts. I'll get in a little bit into technicalities so that you can understand where and why we will need the next scenario. So the MLflow client communicates with the tracking server through a sequence of REST requests in order to record all runs MLflow entities. For artifact logging, the MLflow client interacts with the remote tracking server. For artifacts logging, it interacts with the remote tracking server. And for artifact storage hosts such as AWS, it uses Boto client libraries. It uploads the artifacts to the S3 bucket URI location. Okay, that's a bit complex. In simple words, we can say that the connection between the user and the bucket is direct, right? And while this setup requires DevOps knowledge, it can be useful when you have a lot of runs and the size of your artifacts is large. A point to be noted here is that this direct connection is what gives rise to the next scenario. The scenario 5 is having an MLflow tracking server enabled with proxied artifact storage. So in this case, it's not necessary to grant end users direct path access to a remote storage such as S3 or GCS or HDFS for the management of artifacts, nor is it necessary for an end user to provide the access credentials. So you see there is no more a direct connection between the local host or the user and the storage. You don't have to manage credentials, you don't have to provide authentications. So this is the scenario 5. Now let's come to the scenario 6. So going through all of the above can be a bit of hassle, even for people with DevOps background. And to simplify the process, DagsHub decided to do the MLOps heavy lifting for you. DagsHub provides a free remote ML server with every repository, and this is why we asked you to. You can log experiments with MLflow to it. You can view all the information for these experiments under the experiment tab and manage your train models from the full-fledged MLflow UI built into your DagsHub project. And I'm going to walk you through all of this. And the interesting part is that you can do all of that using only 3 simple commands. When you create a repository on DagsHub, a remote MLflow server is automatically created and configured with the project. The repository's MLflow tracking server can be found at an address which is like dagshub.com, your username, your repository, and .mlflow. However, I have a quicker, easier button-based way to find this MLflow server, which I'll tell you once we are through the part of setting up MLflow on a local directory first. So this is where we're going to get started with the hands-on experimentation. And if you can follow along, that is super nice, because I want you to win this wax and you need to run the notebook and submit it for the same. But in case you miss out somewhere, do feel free to put it in the chat box, but don't worry. Just keep a track of what I'm doing. And once we are done with the webinar, we can help you run the experiment. And yeah, so don't worry, just try following along. And if you can't, it's still okay. Okay, so to demo the MLflow functionality, I choose to use Eric's project, where he's training a model to classify images that hold Mario or Vario. And to shorten the running time, I have created a new branch that simplifies the pipeline and holds the training stage with a small subset of data. And the train.py script that we are going to use for our hands-on has 2 major components. It has a data loader for train, test, and validation set, and it has a super simple small neural network which has just 4 layers. Okay, so that was the introduction to the project. And now I want you all to enter your details into your notebooks. I'm sure you have made a copy of it. And it would need your DagsHub username that you just now created and the email that you used to sign up to DagsHub. I'll go through chat and see if there are issues. Okay. Awesome. So I hope all of you have switched to your notebooks in parallel. And so we have just entered all our credentials. Now we are, you don't have to do any changes here. Just the repo is the repo we are going to get our code and data from. This is the branch which I mentioned has a smaller subset of data for the ease of experiments. And when you'll run this cell, you'll be prompted to enter your password. I'm going to do it super quickly. So the next cell asks you to migrate the repository under your user. So we are using a DagsHub API, and this will migrate the repository under your user. Because I have the repository already, I don't really need to run this cell, but I would ask you to run this cell and get this message that your migration succeeded. Okay. So if you have migrated the project, now is the time. Okay. Now is the time to clone the project and pull the data to the Colab runtime. All you have to do is configure git and run the command to clone the repository. And we have it here. Perfect. Now that we have our repository clone, let's pull the data using DBC, and it will take up a few seconds or a minute to pull the data for you. Just let me know in the chats if you're hitting any walls. Okay, and also I ask you to not run the notebook in one go. Please try following along. We'll run each cells, and some cells require some modification in the code for you. So I have the data in my Colab local. Let's go and check. Okay, yes, I have all the directories that are needed. Perfect. So we have data. And now we'll install MLflow. There are quite a few ways to install MLflow. We'll go with the generic installation of pip install MLflow. You can check out the other options as well to see what suits your needs. Awesome. So we'll start with the first part. In the hands-on, I'm going to walk you through two ways of logging your experiments, logging them locally as well as logging them on a remote server, which are the two most commonly used scenarios. So let's start with logging the experiments locally. So for that, I would ask you to go into the source SRC directory of your repository that you have just cloned on your Colab local and open the train.py file. You can switch to my screen and see that I'm doing it. And there, if once you have opened, all you need to do, the code snippets are already provided to you. You will have to copy paste them once I've explained them to you. So if you have, okay. So once you open your train.py file, you need to import MLflow to it. Okay. So now to get, we need to know the experiment ID to log the runs to it, right? And there are two ways in MLflow to create a new experiment. One is using the command line, which is MLflow experiments create and adding the name to your experiment. And the other one is using the Python API. So right now we're going to create a new experiment using the Python API. We have a script here in the get or create MLflow experiments.py notebook. It's a function where it creates a MLflow experiment for you when you give it the name for it and returns an experiment ID. So we are going to create the experiment and get the experiment ID. So just run the next tab and you will get an experiment ID. It's important to have an experiment ID, and for me it's 1. It might differ for you, so just note it down. We'll need it in the next step. So now we want to allocate a run to the experiment, and how to do that. So we run the command with MLflow.startRun. So what this command does for you is that it initiates a run when you give an experiment ID to it. So it will start logging all your experiments under that, start logging all your runs under that experiment for which you're providing it the ID. And where to add it? So I would ask you to copy it and move the indentation a bit out and just paste it right below where you have your epochs defined, so that all your training and testing procedures can run under this with loop. And you have to enter your experiment number, experiment ID over here. For me, it's 1. So I'm replacing it with 1. Whatever number your last tab gave, last cell gave as an output, you have to paste it here. You have to type it here. So make sure you use your experiment ID and not the one that I am entering. Okay, so now that we have officially started a run, we have allocated the run to this experiment, which is Mario Vario, which we defined over here in this file. And we have entered the correct experiment ID. We'll start logging the information. So before we move on to how to log the information, it's important to understand how it is working. So for logging the parameters, you have the MLflow.log params command, in which you will give it a key value if you're logging a single parameter, or a dictionary if you're logging multiple ones. Okay, so because we are logging multiple parameters here, we're logging 3 of them: image size, learning rate, and epochs. We'll use this format. Then you log MLflow.log metrics. We will use it for logging our metrics. Let's see what metrics we have in our code. So we have our test loss and test accuracy. So that will go in the MLflow log metrics command. And you can also log artifacts and text. However, that is not in the scope of this experiment. I'm not running an experiment which has necessity to log those, so I'm skipping that. And now, because we have multiple parameters, I have the code right any changes and just use it as it is. So where will you add the logging files? It's obvious, you'll add it once you have the experiments running, right? So once you have obtained all the losses, you add the code to log them. This is how we're logging the parameters. And for logging the metrics, let's copy and paste it right where right below where we are logging the parameters. So now you know how and why to log parameters and metrics. So it's time to do a Control-C, Control-S to the notebook. I do it multiple times. I don't know why. And if you're like me, there you go. Once you've saved it, we will run this cell to see the magic. Okay. So while it's running, I'll tell you how an ideal file structure under the ML runs directory should look like. So it should have ML runs as your parent directory. The next directory should be on the basis of your experiment ID. Then it should have a run hash, and all your information should be stored in subsequent directories like this. And if all goes well for us, we'll see that file structure right here, right now. So let's go to the ML runs directory. Yes, I get the experiment ID. My experiment was 1. Okay, I get the hash. There is matrix, and we log test set, accuracy test set loss. We have the parameters that we log. Awesome. So we have successfully managed to log our experiments on the local. Okay, now we'll move on how to log these experiments to a remote tracking server. And this was the part for which I asked you to sign up. A lot of spoilers in the chat. No. The MLflow ninjas move in steps. So we are going to move to the next step. So we can log the experiments to a remote tracking server. Okay, we are going to use DagsHub for it. And to set the remote server with your machine, you need to have an MLflow.setTrackingUI UI command in your code. You need to have your credentials set up as OS variables. And we're going to do those steps right now. Just run these cells and you have everything set up for you. Okay, so now that you have set up the environment variables, let's go back to our code. And okay, what do we need to do now? So we have already run first experiment successfully. For the second experiment, we need to modify the file get or create MLflow experiment.py, which happens to be under the source directory. So we need to open it, and we will add a command to import OS. Super important before you run into any other error. And then add MLflow.setTrackingUI. Awesome. So we are done. Okay, so this is all we needed to do here. 3 times doing in Control-F for safety. Okay, and now we'll run this cell again to get a new experiment ID. We don't want to continue logging the runs in the previous experiment. So we have the new experiment ID. It is 0 for me. And again, just use the one that you get for you. So now we need to add the set tracking UI code in this train.py file as well. We need to import OS, and we'll add it here. Also, the recommended way to do it is to just add the link to the remote server here. But we're using the environment variable because I don't want you to switch from one platform to another in the process of trying to log the experiments. So now that we have added the set tracking URI code, let's change our experiment ID. I got 0. Don't forget to change yours. Okay, now saving the code, closing, and you don't have to move anywhere. As I promised, you will see your DagsHub dashboard right here. You will see your repository in this cell. Just run it, and under the experiments tab, you will see the experiments. There are the files. Okay, let me go and rerun the code so that we can see the new logs. Awesome. So I run this code, and when it executes, we'll see a new experiment being created here. So as I promised that you won't need to type a server or like do a manual process of getting to your server, there's a button-based way. I just love this. You can simply go here in the MLflow remote option and click on go to MLflow UI to go to the MLflow UI. Okay, let me add my details. I'm not sure. Okay. Okay, and here you can see, okay, do we have the new run logged already? That was super quick. Let's go to the experiments tab. Okay, it was quicker than my expectation. We have the new run logged here already, and you can see all the parameters that we were logging. You can see the image size, you can see the learning rate, the epochs, the test set accuracy, as well as the loss. Awesome. So we are done with logging our experiments on local as well as remote server. Now coming to the last part. So if you're a forgetful human logger like me, who always forgets to log something to the tensor board or the outputs, you will probably appreciate this feature the most. Automatic logging allows you to log metrics, parameters, and models without the need of explicit log statements everywhere, wherever you want to log the metrics or the parameters. MLflow Autologger supports a lot of libraries. I have listed them all down for you. And you can use MLflow.autolog to enable logging for all of them, or calls for each library. So I'm going to use a library specific autolog call for you here. TensorFlow.autolog, and we have to add it right above the call where we did with MLflow.startRun. So before you initiate your run, before you start running your code and logging the experiment, you will call to the autologger so that it knows that now it has to start logging stuff for you. Okay, there it goes. Just you can add it here, or okay, let me do as I instruct. So add it right here, just before where you start your with MLflow.startRun and the experiment ID. Okay, so there we go. A Control S again, and we run the code cell. No sneak peeking to the next part. We're not an MLflow tracking ninja yet. So we'll go back to the experiment table and see how autologger performs for us. Okay. Awesome. Here we come on the experiments tab. I see a new experiment logged. Awesome. A few seconds ago, the autologger did its magic, and we have all the metrics being extracted by the autologger. Perfect. So we are at the end of our tutorial, and now here in MLflow Tracking Ninja, I should have probably put an asterisk right over there, because you're not an MLflow Ninja right now. You are an MLflow Tracking Ninja, because you have one more tutorial to go till you become an MLflow Ninja. I hope that you're comfortable with MLflow tool now, and you would consider it as your go-to ML workflow management tool, just like I do. And if you have doubts, you run into errors, or you would like to share your experience, please feel free to join our Discord and join us as we build our community stronger each day. See you on 27th of September, where my MLflow Pro friend Leono will show you how to register ML models and deploy them with MLflow. So that was it from me. Feel free to join us on the Discord server for your questions. And here's a quick link. Okay, thank you. I'll stop sharing my screen. Please feel free to ask your doubts and share your notebooks and the link to your repository and experiments if you follow along.
So at this point, yeah, we're going to open it up for Q&A. So before we do that, I want to thank Shambhavi for her great session. Yeah, she deserves some claps. So if you can use the emojis or your cameras. So if you have questions, we have Shambhavi here. We also have our MLflow specialist, Simon, who was in charge of doing the MLOps heavy lifting on the DagsHub side and in charge of the integration. We also have Dean here, our founder and CEO, and Megan, our community manager. So we have the entire DagsHub team here, not the entire, but people that are relevant and can help you. Yeah, the entire team is bigger. So if you have any questions, feel free to raise your hand here and I will unmute you. or send it out on the chat. It can be regarding MLflow, hopefully, or if you have other questions regarding MLOps, ML, DagsHub, you name it. So Ali, you can go.
Hi, you guys can hear me?
Yes, loud and clear.
Awesome. I just have one question. Rather than going and editing the files itself, I know it is good to make the psychological process of changing things and and using CLI, we could have just passed the environment variables, for example, the experiment IDs. So rather than going to the file and editing manually, we could have just passed a CLI and behind the scenes as an argument, it could be passed. So if you guys allow me, I can do such kind of things and I can open up a PR if the notebooks are available on DagsHub.
Definitely. So thank you very much for wanting to contribute. We're gonna push the notebook to the MLflow 101 branch, and we'd love for you to open a pull request and contribute it to it. It's an open invitation to everyone. So if you want to contribute from your knowledge about MLflow, or more specifically to MLflow tracking, because this is what we covered in the MLflow 101, then we'd love that. Right after the session, we're gonna push Shambhavi's notebook to that branch, and feel free to fork, open a pull request, make the modifications and open a pull request. The cool part about DagsHub is that you can also diff very large notebooks with a lot of outputs, then it will be very easy to review. And we'll have someone on the team reviewing it, or maybe the MLflow Grandmaster, Simon himself. And we'd love that. So thank you.
Thank you so much. Thank you so much. Actually, I've been using MLflow for quite a time. I'm using PyCaret. I hope, have you guys heard about PyCaret? So PyCaret by default integrates MLflow into the thing. It's an Python-based AutoML library. Right now, 4 million data scientists are using it. So it's awesome. And thank you so much for this workshop.
This might be a coincidence, but just today, the creator of PyCaret released a blog on how to use PyCaret, MLflow, and DagsHub. So I just sent it on the chat. This is awesome. It was just released today, so I'm not sure if you planned it or not. But if you did, so thank you. And if not, then that's amazing. So if you want to learn how to use PyCaret, MLflow, and DagsHub, this is a great resource by the creator of PyCaret, Moise, which I highly value. So yeah, so this is funny, and thank you. I had it on my reading list.
Awesome, super awesome. Thank you so much. Thank you so much for this awesome workshop. Looking forward to the second one.
Definitely.
Desperately looking forward.
We're gonna register and deploy some models. So this is this is exciting to bring ML to life and deploy it and have people interact with it and creating, I don't know, endpoints and very cool stuff. Yeah, the part 2 is definitely going to be cool. And also, as Shambhavi mentioned, Yona is going to take the lead for this session. Very experienced ML engineer, and I can't wait to be part of this session. So I'm looking forward to it. Thank you, Ali. Yes, so Abhishek. Hopefully I pronounced it correctly, Abhishek.
Yeah, not at all.
Yeah, I'm good. I'm bad with that.
Okay, so I primarily have 2 questions around MLflow. So first is around how do you think about creating an experiment, right? So I'll just try to give an example. So suppose very simple example, right? So you just want to have the best model given a data set. You want to train the best model. So in my mind, I will start by structuring my first experiment as just comparing across 10, 15 one experiment. And then when I decide my top 3 models, then I create 3 more experiments to tune random forest, to tune let's say XGBoost, and then to tune CatBoost. So that is how I should go about structuring experiments, or put them all into one experiment and create lots of runs around that. That is something that really troubles me as to how do I think of something that comprises an experiment, then do runs around that.
I lost you for like 4 seconds. That probably were the most important part of what you asked. So if Dean or Simon heard it, you can take it. And if not, I will ask you to shortly repeat it.
Yeah. So basically, I just want to ask, how do you think about structuring your experiments? So do you make one big experiment and do lots of runs in that experiment, or do you make like 10 small, very focused experiments and do like moderate amount of runs in that?
So this is like mainly workflow and whatever works for you. So there's no right approach or right answer here. What I would say that, or what works for me, and it says Shambhavi mentioned in their session, is I consider experiment as the overarching hypothesis that I want to check. So she gave the backbone model as an example. In this case, we can either check between different models, as you said, so XGBoost, random forest, and I don't know, neural nets. And that will be the overarching experiment. And we're going to name it like choosing a model. And inside that, we're going to have different runs where each one is going to be with like changing the code to the different model, committing it, and then starting the run. This way, MLflow would log the commit hash to your run, and you'll be able to reproduce it easily. And you also have the parameters that you used and the metrics, so the output of the model. And then you can compare between the 3 different runs, choose the best one. And under this experiment of choosing the best model, you can specify which run was chosen as best with, I don't know, you have probably your golden metric. Revert back to that commit, check out. On this note, if you're going to also version your data and other components, you'll be able to retrieve all of those versions. And this is like full reproducibility. This way you can fully reproduce that experiment and then move on to the next hypothesis. So you chose random forest. Now you want to do hyperparameter tuning, right? So hyperparameter tuning is going to be the experiment, and each run is going to be different set of hyperparameters.
Got it. I think that's how I also think about structuring the experiment. So that's really helpful. And second question is sort of related to that. So as you start doing more and more runs, so that means that in each run, suppose you're logging your model, right? And you're logging some artifacts, and so that will inevitably lead to a lot of space in your artifact store, right? So how do you retrospectively go to your runs and sort of prune your runs? And also, supposing I made a mistake in one of my previous runs and I want to correct the information around that. So is there an easy way to do this retrospective run correction in MLflow?
So delete a run, or let's say you, I don't know, you log the hyperparameters with which like it wasn't, I don't know, the max depth of your tree wasn't 10 nodes, it was 9. That's what you mean.
Maybe you forgot to log some of the parameters, but you know that these were to be logged as that.
So to add extra
it's
logs.
Stored in a, yeah.
So adding extra
stored in
logs.
A SQL, yeah.
You go.
Go on. Yeah. So I was just thinking, since it's stored in a SQL store, right? So maybe there's a database, right? It's stored in SQLite or Postgres. You could just check into that and correct the run, or the MLflow API allows that to be done in an easy way.
As far as I remember, MLflow does support modifying runs, but I will leave it to Simon because I'm not 100% sure about it. So Simon, you will take it in just a sec about like if we can modify runs. I will take the first question, which is how to balance between the artifact that we're logging and the space that it might take. So yes, so it really depends. So let's say that it might take you 1 week to train your model, and it takes a lot of compute power, then it's going to be very costly to log your to run the training process. And meanwhile, your model can be also quite big. But as far as I know, the computing costs are higher and like large scales than storage. Then from my end, I would rather like storing all the artifacts and all my models in order to be able to go back to a previous, like a pre-trained model, instead of wasting another week of computing and training my model. However, on the other end, or the other like side of the spectrum, if it takes you 10 seconds to train your model, and it's just like running fit predict for like 10 seconds, and you're going to end up with too much of artifacts that might be too big, then I wouldn't hassle about it. I would just like log the parameters, the metrics, and this way I will find the best one, reproduce it by running the experiment one more time, and then logging the artifacts. And keep in mind, and we're going to cover it in the second part, I don't want to jump ahead because we're focused on the experiment tracking, is that you can log the artifacts, but you don't register all of them in your model registry. You can choose the best ones you want to register, and this way you can differentiate between everything and the interesting models. So it's like you can think of it like a production state, or all the models that are relevant that you want to test or that provided any good results. So this is the way I differentiate between the two. And I will let Simon answer about modifying experiments. Simon? Oh, you can unmute yourself. Okay. Now you can. Yeah. Sorry.
Yeah. So with regard to editing runs, so you can do that. MLflow provides an API for that. You have an API function, which is I think it's get run, and then you can get a run using the run ID, or you can search a run to the MLflow documentation. But you can certainly load an active run. So what MLflow does, it has like it has some kind of singleton active run that you need to just load any run into it. When you do start run, then that new run becomes the active run, but you can load any run to be the active run, and then you can actually log params, new params, and even new metrics. You can change everything into that existing run. With regards to storage and pruning, like right now, the idea is that the artifacts are stored in a, like, if your question is in general, you can access your, like, if you're using MLflow unrelated to DagsHub, you can always access your storage and prune it manually. I don't think that MLflow has an API to control the artifact store, but it doesn't provide right now a delete function, as far as I know. Maybe in the near future. So on DagsHub, we're using object storage to store the artifacts. That's what you should probably use anyway with MLflow. So you can store a lot of data, and it's quite cheap in general. So that shouldn't be a problem. And also removing and pruning data actually breaks reproducibility, but that's under your control.
Yeah. I think that's really helpful. And one thing I would really like to point out about MLflow is that at my workplace, people, my coworkers, use MLflow for not just the ML stuff. So any sort of job that you want to run, you can sort of track anything and keep track of the reproducibility of that. Right? Does not need to be always machine learning models.
I hope it helped. Thank you for your question and for participating. If someone else has other questions, we're here and we'd love to hear them. So just like raise your hand or write on the chat. I'm looking. Also great to see some familiar faces. So shout out to Abid that I see you're here. Love to see you here. One of our power users. Been with us from the early days of DagsHub. So it's great seeing you here, Abid. Does MLflow have something similar to weights and biases? Sweep for running parameters searches. I'm not familiar with that. Dean, you want to take it?
Yeah. So sweeps is sort of the hyperparameter search running functionality. MLflow is basically not an orchestrator, so it does not run experiments for. But as far as I know, all of the hyperparameter tuning capabilities in most of these tools are based on either RayTune or Optuna, which are open source, and so you can use those with MLflow. I think there are many blog posts about this. I could probably search for one in a moment and share it, but that would be sort of equivalent to sweeps, and you can use those. I think sweeps also requires that you provide compute for running it. So, but I might be mistaken about that part. So I'll share something in a moment. That would be the equivalent in MLflow.
Thanks. And we have another question about in the chat, which is, can we perform feature engineering in MLflow pipelines? As far as I know, it's not possible. I feel like this is a very new feature that MLflow just released. Dean, do you have any knowledge about feature engineering with MLflow pipelines? As far as I know, it provides you the ability to also pre-process or post-process the data for sending it to your model to get the model prediction. So currently you can deploy only the function that predicts. And with MLflow pipelines, you can also create a pipeline from getting the data or the input from the user to the endpoint, process it, get the model's prediction, post-process the model's prediction, and then send it back to the request. But Dean, are you familiar with feature engineering or more like something in those areas?
So this is a bit more related to the topics that we'll cover in the next part of the webinar. Generally speaking, MLflow supports arbitrary functions. They call it PyFunc models. So basically, you can put whatever you want there, including feature engineering, including non-ML code, and it will work, assuming it conforms to the interface. If you're referring to multi-stage pipelines, that's something that MLflow is trying to solve with MLflow pipelines, which has been recently released. It's still, as far as I know, experimental. So that is supposed to cover that part. I haven't tried it just yet, so I don't know if it's good or not. But yeah, that's sort of the current answer I have.
Yeah.
So hi, thank you for answering my question. Basically, I have been researching on MLflow because I just want to bring it in my organization. So right now we have a manual system for all the models and everything, but I thought it's a good idea to bring MLflow. And the one problem that I have been debating upon is is it necessary to use a feature store before MLflow? Because if I have a feature store, I want to perform some ML feature engineering. So that's what I have been debating, and that's why I asked this question. Because as far as I know, feature engineering is not possible in MLflow. It's just you need a data, and then you can just train your model with different parameters and everything. Is that correct?
So if we're talking about feature stores in general, part of the pipeline, if you will, there's maybe a bigger discussion. Maybe this is a part of a different webinar or event. But yeah, go ahead. Sorry.
Yeah, because the purpose, what I'm asking, let's say we have the raw data in our sitting in our SQL or PLSQL database, right? And I was thinking, if it a right idea to directly send that data in MLflow, or should I need one layer where I can just perform some transformation, make the data ready for the model training? That's what like I have been confused. Should I use directly MLflow, or should I add one layer for feature store or some data transformations?
So MLflow is not built for data management, basically. If you, it is built for, it manages the data of the experiments, right? But not the data that the model is being trained on or processed. So MLflow sort of is sitting above your data pipeline. It receives information from perhaps the entire pipeline, but usually from the training part. And that helps you make decisions on what experiments are more promising, what models you should deploy to production, but it's not a substitute for a data management solution. With DagsHub, for example, we provide the data management solution based on Git and DVC in addition to MLflow. But if you are working with a database, then you have a database where your data is stored, you would probably do a query where you bring in some part of that data set to train a model on. And then once you train that model, you are reporting metrics and parameters and everything that Shambhavi mentioned back to your MLflow server. So that's sort of the relationship there, if I understand your question correctly.
Got it. Yeah. Thanks for clarifying the question. I got it. Thank you.
Sure.
Any more questions before we wrap it up? Okay, so yeah, we don't have anything in the chat, and there's a party going on in the street probably. I hope you don't hear it. Cool. So I want to thank you all for joining us today. I want to thank Shambhavi for taking the time and effort into building this amazing session. I feel like it was a good combination of theoretical and practical part, and I really enjoyed listening to it. And I also learned, although I knew MLflow, I learned a lot about it in the process. So thank you so much, Shambhavi. As we mentioned in the very beginning of this session, we are gonna draw 5 full DagsHub swag packs to people that participated in the event. So what you need to do is go to our LinkedIn account. You have the post about the webinar there. Send or comment there with the repo that you just created on DagsHub, with the experiment that you generated, and we're gonna draw those swag packs and send them all the way to your home. So if you want to be part of it, just feel free to send them there. I also am gonna shoot here because we had a lot of good questions. If you have follow-up questions, I'm sending a link to our Discord. We have a support channel there. It's unrelated to that, like it's related to DagsHub, but if you have questions that are unrelated to DagsHub, they're about MLflow, about DVC, about MLOps, about life, feel free to send them there. We'd be more than happy to help you. This is our way to contribute back to the community. So really feel free to send your message there, to share your projects, share what you're working on. We tend to help as much as possible to community members and also people that are non-DagsHub users, because this is our way to contribute back. So I want to thank you all for joining today, and have a great rest of your week and great rest of the day. Thank you so much. Bye-bye.